Hello everyone, welcome back to Embedded System course. So we were discussing chapter number 1, that is 8051 programming in C. Now we are in lecture number 4. So in last lecture, video lecture, lecture number 3 part number 2, we discussed on how to write time delays for 8051 microcontroller in C programming, as well as we studied about IO port programming of 8051 ports in C. In this lecture, we are going to proceed further. That is next point, that is logical operations in 8051 using C. Okay, so that is logical operations means you have studied in digital techniques course what are basic logical operations like and, or, not, XOR, etc. So how to perform such logical operations uh, for 8051 microcontroller in a C programming language, that we are going to study in this lecture. Okay, so there are two categories of logical operators available in a C programming language to perform logic operations. First category is byte-wise logical operators. Byte-wise logical operators because these operators operate on whole bytes. Okay, for example, and for AND operation, double ampersand is the logical operator available in C programming language. So this operator can be used to operate on two operands, that is data 1 and data 2. Okay, and this operator operates on whole bytes of data, that is the meaning. Okay, so byte of data we can categorize it as logic 0 or logic 1 or true or false. If that data is non-zero means it represents true, that is 1, and if that data is 0 means that represents false. Okay, so according to that, this byte-wise logical operators performs and produces a result either true or false. Okay, so for AND operation, this is the operator, that is a double ampersand. For OR operator, double bar is the operator in C, and for NOT, that is inversion operation, exclamation mark is the operator. Okay, so for and OR logical operations or byte-wise logical operations, we require two operands, that is 2 bytes we will require for first these two operators, and for this third operator, that is not byte-wise operator, we require only one operand, that is 1 byte. Okay, so that byte could be, as I told you, it could consist of non-zero value or zero value. If it consists of non-zero value means it represents true. If it consists of zero value, that means it represents false. And if we operate not operator on such data, okay, then if that byte represents non-zero means true, it becomes false after this not operator operates. And if that byte consists of value 0 means it is representing logical value false or 0, then that will be inverted and that will become that is non-zero value means it will represent true value. Okay, so this not means inversion, it just invert logic in the data byte or operand on which it is operating. Second category of logical operators are bitwise logical operators. Okay, so instead of operating on whole byte, okay, these bitwise operators operates on bits, or it operates bitwise. Okay, for example, first bitwise operator and its operator is, instead of here bytewise, in case of bytewise, double ampersand was there, that is a bytewise AND operator, but bitwise AND operator consists of only single ampersand. Okay, this is nothing but bitwise AND operator. How to use it? Suppose data 1 and data 2, in between data 1 and data 2 we have to place this single ampersand. Okay, so data 1 is 8 bit of data, and data 2 is also 8, or should be 8 bit data. Okay, now how this bitwise AND operator operates on these 2 bytes. Okay, so what uh, it will do bitwise operation, ending operation. Means how? So it will take D0 bit from data 1 and D0 bit from data 2, and it will perform ending operation. Okay, and after that ending operation, whatever result it gets, it will store in the resultant um, byte at the place of D0 bit. Similarly, after that it will do ending operation between bit D1 in data 1 and bit D1 uh, of data 2, and whatever result that it will place in position of bit D1 in resultant byte. In this way it will go up to bit number D7. Okay, so in this way bitwise AND operator operates on this data 1 and data 2. Okay, means ending operation, bitwise ending operation takes place and it produces resultant byte. Okay, similarly OR operation, bitwise OR operation, for that operator, that is single bar is the operator. XOR operation, so for that operator is single caret. Inverter, bitwise inverter, that is not operation but bitwise, for that there is a operator, that is tilt. Okay, so for OR and XOR, syntax of using these operators same like uh, and bitwise AND operator. Okay, but here inverter, bitwise inverter operator operates on single operand, that is single data. Okay, it inverts it. For example, here data is suppose 1010 1010, then after inversion data will become 01010101. Okay, next bitwise operator is a shift, right shift. Okay, so syntax of using this data that is to be shifted, and then um, this is a shift right operator. Okay, shift right operator. So it will shift data in the given byte, um, okay, towards right. Okay, by how many position, that will be specified by the number given. How to specify that number? So this is the syntax. So this is the data byte, okay, which is to be shifted. Then this shift right operator. Okay, so that is greater than, two greater than operators. Okay, and then number of bits to be shifted. For example, here if I write data shift right operator and 2, that means whatever bits in data, that will be shifted by 2 position, okay, towards right. Similarly, shift left operator. Okay, so the symbol is exactly opposite, or operator is exactly opposite as compared to shift right operator. So this operator, that is a double less than sign. Okay, its syntax is like shift right. Here for example, data shift left operator, and number of bits to be shifted left. Okay, so here this this shift left operator will shift data bits in this data, okay, by number of bits that is specified after this operator. For example, if here if I write data and shift left operator and 5, so what will happen? So data bits in this data will get shifted 5 times towards left. Okay, that is the meaning. Okay, so these are bitwise operators. Total 6 bitwise operators are there, and these are the actual operators that we will use while programming. Okay, so single ampersand means and, bitwise and operator. Single bar means bitwise or operator. Caret means bitwise XOR operator. Inverter means, bitwise inverter means tilt operator. Okay, shift right means greater than operators. Okay, shift left means less than operators. So we use these operators while programming, okay, to do logical, bitwise logical operations. So here is an example that illustrate how these bitwise logical operators operates when we use it in a program. For example, here A and B represents single bits. A and B represents single bits. Okay, and A ampersand B means bitwise AND operator. So what will the result that is given here? Okay. Then A bar B means bitwise OR operator. So under which result is given. Caret means A caret B means bitwise XOR operator, and tilt B means inversion, bitwise inversion operators. So if A and B are single bits, and in between these single bits, if I do bitwise AND or XOR and inverter operation, then what will the result that is given in this table? So suppose bit A is 0, bit B is 0, then A ampersand B. Okay, so there will be bitwise operation between these two bits. Okay, so A bit, B bit both are 0, so result will be A ampersand B will be 0. A or B, or A bitwise or with B produces 0 because these both are 0. XOR also produces 0, and inversion, so this inversion on B, only B, okay, because inverter operator operates only single operand. So here I have taken B as operand for this inversion operation. So if B is 0, so after this inverter bitwise inversion operator on data B, it becomes 1. Okay, then if AB 0 1, A ampersand B produces again 0, A or B produces 1, and XOR operation produces 1, and tilt B, that is inversion of B, B is 1, so it becomes 0. Okay, similarly if A is 1, B is 0, and operation produces 0, or operation produces 1, XOR produces 1. If A B both are 1 1, then A ampersand B will be 1, A or B will be 1, and A XOR B will be 0. Okay, so in this way these bitwise logical operators operates. Okay, so here for example we have taken here A and B as single bits, but A and B could be number of bits. Okay, in that case there will be bitwise operation on respective bits in A and B operands. So now we will take example to illustrate use of these bitwise operators in a C. So here run the following program on your simulator and examine the result. Okay, so here hash include reg51.h. We have included this reg51.h header file. Then void main program is written. Now see here P0. P0 means port 0. So P0 which is defined in reg51.h, so that we can use this symbol here P0, P1, P2, etc. So P0 is equal to 0x35 ampersand, single ampersand means it is a bitwise AND operation, 0x0f. Okay, so this is 1 byte of data, this is another byte of data. So in between these 2 bytes I am doing bitwise ANDing operation, and whatever result that will get put on this um, port 0. Okay, now we will see here what exactly happens. So I will use tab pen here. Okay, so here this 35 means 0 0 1 1 0 1 0 1. Okay, and this 0f means 0 0 0 0, f means 1 1 1 1. Okay, now in between these two bytes, okay, so this is actually 35H or 0x35, and this is 0F H. Okay, now in between these two bytes, okay, so bitwise ANDing operation, how it happens? So this is D0 bit from 35H and D0 bit from 0FH. So there will be bitwise ANDing operation between these two bits. It produces 1. Okay, in between next two bits 0 1, it produces 0, ANDing operation. Here 1 1 produces 1. Here 0 1 produces 0. Here again 1 0 produces 0. Here 1 0 produces 0. Here 0 0 produces 0. Here 0 0 produces 0. So what is answer? That is 0 5. 0 5 H is the result of bitwise ANDing operation between 0x35 and 0x0. So this 0 5 will get outputted to port 0. Got it? Okay. Now next operation is P1 is equal to 0x04, and this single bar means AND wise and OR wise, uh, bitwise OR operator. That means there is a bitwise OR operation between data 0x04 and 0x08. Okay. Now let us see this. Okay, now we will perform this bitwise OR operator. So this data is 0 0 0 0 0 0, and 4 means 0 1 0 0. So this is 0 4 H. Okay, next 68. So 0 1 1 0, this is 6, and it means 1 0 0 0. Now between these two bytes 0 4 and 0 8 68, sorry, so there is a bitwise OR operator. So between these two bits 0 0, bitwise OR produces 0. Again 0 0, it produces 0. 1 0 produces 1. 0 1 produces 1. 0 0 produces 0. 0 1 produces 1. 0 1 produces 1, and 0 0 produces 0. So in hex this will be 6, and this is how much? C. Okay, so this is 6C is the result of this bitwise OR operation between 0x04 and 0x68, and this 6C, that is the result of this bitwise OR operator, that will be outputted to port 1. Okay, so this is bitwise OR operator. Okay, now next is uh, 0x54 caret 0x78. Okay, that is a bitwise XOR operator between data 0x54 and 0x78, and result will be outputted to port 2. Now see how this operator operates. Okay, so this is 0x54 means 0 1 0 1, and 4 means 0 1 0 0. Okay, so this is 5 4 H. Okay, and next is 78. 0x78 means 0 1 1 1 1 0 0 0. That is, this is 78H. So bitwise XOR operator. So 0 0. So first bit is 0 0. This produces 0 0. 0 0, it produces 0. 1 0 produces 1. 0 1 produces 1. 1 1 produces 0. 0 1 produces 1. 1 1 again produces 0. And 0 0 produces 0. Okay. So this will result in what is 2C. So result is 2C. Okay. So bitwise XOR operation between this 0x54 and 0x78 produces 2C, 0x2C or 2CH, and that will be outputted to port 2. Okay. Next is this is bitwise uh, inversion operation. So 55 means 0 1 0 1 0 1 0 1. So when this bitwise inversion or not operation operates on this 0x55, that is 0 1 0 1 0 1 0 1, data in this byte will get inverted bitwise, means this 0 will become 1, this 1 will become 0, this 0 will become 1, this 1 will become 0 1 0 1 0. So result will be, what is this? A, this AAH will get outputted to port 0. So after inversion of 0x55, AAH will get produced and that will get outputted to port 0. Okay. Next, P1 is equal to, so let me first erase this part. Okay. Now next is shift right by 3 position. P1 is equal to 0x9a and greater than sign T3. That means shift data 9a, okay, by 3 position towards right. Okay, so 9a here will be, this will be 9 means 1 0 0 1, and a means 1 0 1 1 0. So this will be shifted 3 times towards right. Okay, so this will be shifted towards right, okay, by 3 position. So uh, due to first shift, what will happen? So this whole data will get shifted, means data will become 0 1 0 0 1 1 0 1 after single shift, right shift. Then again one more shift, that will shift this data towards right. So 0 0 1 0 0 1 1 0, and one more shift because it is being shifted 3 times. So again 0 0 0 1 0 0 1 1. Okay, so this data is in hex, it is 1 and 1 3. So 1 3 is the result after shifting this 9a by 3 position towards right, and that will be outputted to P1. Now see here, while shifting towards right from left, zeros will get appended here. Okay, so that is the this is not rotating through this byte. Okay, it is shifting. This is not rotate operation, this is shifting operation. So towards left, zeros are being appended here. Okay, and data is being shifted here. When it shifts 3 times, it produces hex data 1 3h, and that will get outputted to port 1. Okay. Similarly happens with next statement, that is a P2 is equal to 0x77 shift towards right by 4 position. Okay, similarly happens with we'll do this last one. So here in this case, okay, this we will do. So 0x6 means it is 0 0 0 0 0 1 1 0. This is what 06H. Okay, so it is being shifted towards left by position 4. Okay, so first time it shifts, what will happen? So I will write from here. So 0 0 1 1 0 0 0 first time. Next time 0 0 0 1 1 0 0 0. Third time 0 0 0 0 1 1 0 0. Fourth time 0 0 0 0 0 1 1 0. So result will be, that is, this is what, this is 660H. Okay, so this result, so this 0x6 left shift by 4, this produces data 60H. Okay, so that will get outputted to port 0. Okay, in this way these bitwise logical operations works. Okay, now next program, write an 8051C program to toggle all the bits of port 0 and port 2 continuously with 250 millisecond delay using the inverting and XOR operators respectively. तर काय करायचं आपल्याला, तर पोर्ट 0 आणि पोर्ट 2 चे बिट्स जे आहेत ते कंटिन्युअसली काय करायचे, टॉगल करायचे. ओके, म्हणजेच पहिल्यांदा 0101 0101 आउट करायचं आहे पोर्ट 0 आणि पोर्ट 2 ला. नंतर काय करायचं आहे, 1010 1010 पोर्ट 0 पोर्ट 2 ला आउट करायचं आहे विथ 250 मिलीसेकंड इन डिले इन बिटवीन. परंतु त्यासाठी काय यूज करायचं आपल्याला, इन्व्हर्टिंग अँड एक्सऑर ऑपरेटर. So for that program is written, so hash include reg51.h, then void ms delay unsigned int. So this ms delay is a function name. Okay, so this whole statement is function declaration. We are declaring ms delay as a function to which we are passing unsigned int type of data, single data. Okay, so this ms delay function will generate a particular delay, okay, of the value we are passing to this function. Okay, so this is function declaration. We are declaring this function because we are using this function from main function, and this definition of this function is coming after this main function. Okay, so here below main function we are writing ms delay function, so we are required to declare this function in the start. Okay, then void main void, see p0 is equal to 0x55, p2 is equal to 0x55, means first we are outputting 0x55 to port 0 and port 2, means we are making bits of port 0 and port 2 0101 0101. Okay, then while 1 means infinite loop, so whatever statements in the loop will be continuously executed infinitely, that is the this infinite while loop, because this condition for continuation is always true, means non-zero value 1 means this condition is always true. So whatever statements in the loop will be repeatedly or infinitely executed. So what is written here, p0 is equal to, what is this, bitwise and not operator. Okay, so bitwise not operator on port 0. So presently what is data in port 0, 55 we have outputted, so that will be inverted. So after inversion of 55, what data we will get, we will get AA, because what is 55, 55 is, now see here, 55 is 01010101. So after this inversion operation on port 0 मध्ये काय आहे, 55 means 01010101. So after this bitwise inversion operator or not operator operates on port 0, Okay, so it will invert the content in port 0, means it will make this 0 bit 1 because it is bitwise operator. 0 1 1 0 1 0 1 0 1 0. Okay, so it will become AAH, and that will get outputted to port 0. Okay, so here we are doing this inversion operation by using this inverting operator that has been asked in the statement. Okay, now next, P2 is equal to port 2. This caret means bitwise XOR operator, and we are XORing FF with this port 2 contents. Now see what happens. Port 2 मध्ये काय आहे सध्या 55 0 1 0 1 0 1 0 1. Okay, and there will be bitwise XOR operation between this 0 1 0 1 0 1 0 1 and FFF, sorry, FF. So 1 1 1 1 1 1 1 1. So see the result. So bitwise XOR means 1 1 becomes 0, 0 1 becomes 1, 1 1 becomes 0, 0 1 1, 1 1 0, 0 1 1, 1 1 0, 0 1 1. So what this data is? It is actually AAH. Means we are using this XOR operator to invert content in port 2. Okay, so previously it was 55, now it becomes AA. Okay, means just we have inverted it, and that we are again assigning to port 2. Means to port 2 what I am outputting AH, which is inversion of previous content, that is 55. So we are using XOR operator for the inversion here. Okay, then we are calling delay subroutine that produces 250 millisecond delay if particular microcontroller and oscillator frequency of 11.0591 is used. So this MS delay subroutine written here, it produces 250 millisecond delay. Okay, so these loop statements continuously executing means it is continuously toggling data in port 0 and port 2. Okay, so in this way we can write this program. Okay, so let us move to next. Okay, next program is write an 8051C program to get bit P1.0 and send it to P2.7 after inverting it. काय करायचं आहे तर पिन नंबर 0 पोर्ट 1 ची जी आहे त्याच्यावरचा डेटा जो बिट आहे ती पिन वरचा जो काय बिट आहे 0 or 1 that we have to read, we have to invert that, and that inverted bit we have to send on port pin number 7 of port 2. So see here, include reg51.h. so S bit in bit is equal to P1 caret 0 semi-comma. So this statement is declaring in bit. Okay, in bit as S bit type of variable, and to this in bit I am assigning address of pin number 0 of port 1. म्हणजेच काय तर ही pin number 0 of port 1. Okay, I am representing by using this in bit symbol. Similarly, I am declaring out bit as S bit type of variable, and to which I am assigning address of pin number 7 of port 2. Okay, म्हणजेच काय by using this out bit symbol I am representing this pin, that is pin number 7 of port 2. Then bit mem bit semi-comma. So this again declaring mem bit as a variable of type bit. म्हणजेच काय mem bit, in mem bit I can store 1 bit of data. Okay, then void main function. Okay, and in this main function there is infinite while loop. While 1 means infinite loop, means whatever statements in this loop will continuously or infinitely executed. Okay, so what are statements in this loop? Mem bit is equal to in bit. Okay, so mem bit is one variable which can store 1 bit of data. So mem bit is equal to in bit means what? In bit means port 1 pin number 0. So what I am doing here, I am getting what is data, okay, on this pin number 0 of port 1. Means I am reading data on pin number 0 of port 1, and I am storing that data in mem bit. Okay, then out bit is equal to, this is bitwise inversion or not operation. Okay, so that is tilt. So outbit is equal to tilt mem bit. ओके, तर मेमबिट मध्ये आता काय आहे, तर पोर्ट 1 पिन नंबर 0 वरचा जो का डेटा रीड करून घेतलेला आहे, सो दॅट इज अवेलेबल इन मेमबिट. आय एम इन्व्हर्टिंग दॅट मेमबिट डेटा, म्हणजेच काय, अगोदर तो 0 असेल तर 1 होईल, 1 असेल तर 0 होईल, अँड दॅट वी आर assigning to outbit. But what is outbit represents pin number 7 of port 2. म्हणजेच काय, we are outputting data in membit. Okay, first we are inverting it and then we are outputting to pin number 7 of port 2. म्हणजेच काय, what we are doing by using these two statements, I am reading data from pin number 0 of port 1, then inverting it and then outputting it to pin number 7 of port 2. Okay, so this is the program. Next, write an 8051 C program to read P1.0 and P1.1 bits. म्हणजेच काय, port 1 pin number 0 and port 1 pin number 1 we have to read and issue an ASCII character to port 0 according to the following table. Okay, so P1.0 P1.1 जर का या दोन पिन्स वर डेटा 00 असेल तर we have to send ASCII code of number 0 to port 0. If sorry, sorry. So if these bits P1.0 P1.1 are 0 1, then send ASCII code of number 1 to port 0. Similarly, if these bits are 1 0, then send ASCII code of number 2 to port 0, and if these two bits are 1 1, then send ASCII code of number 3 to port 0. This is the program. Okay, so for this we have to write program. So the program is written: include reg51.h void main. Okay, function void main void, and in this function unsigned char z, we are declaring z as unsigned char type of variable. Means in z I can store any value in between 0 to 255. Okay. Then z is equal to p1 semi comma. So by using this statement, what I am doing, I am reading port 1 and whatever data in port 1 I am storing in z variable. Okay, then see, z is equal to z ampersand 0x3. Okay, म्हणजेच मी आता काय करतोय, so let us do it. So here first I am reading port 1 data in z, and then I am doing z whatever z. Okay, so d7 d6 up to d0 bits of in z, and z मध्ये मी काय रीड करून घेतलेला आहे, port 1 मधला डेटा. Okay, so I am ending this data with 0x3, means 0 0 0 0 and 0 0 1 1. ओके, म्हणजेच काय, मी फक्त हे d0 आणि d1 बिट्स, ओके, आय एम कीपिंग ॲज इट इज अँड आय एम मास्किंग रिमेनिंग बिट्स. ओके, म्हणजे पोर्ट 1 मधला जो का डेटा मी झेड मध्ये रीड करून घेतलेला आहे त्यापैकी फक्त d0 आणि d1 बिट्स वी आर ऑफ इंटरेस्ट, कारण आपल्याला p1 इथं पोर्ट 1 चा बिट नंबर 0 आणि बिट नंबर 1 प्रमाणे we are going to send ASCII code of 0 1 2 or 3 to port 0. Okay, so we are masking remaining bits from d2 to d7, and we are keeping d0 and d1 bit as it is available in z. So for that I am doing this operation. Okay, so now what is available in z? It could be either 0. Z मध्ये काय अवेलेबल आहे आता? It could be value. Okay, so 0 0 0 0 0 0 0 0 or 0 1 or 1 0 or 1 1, because these remaining bits are masked. Okay, so in a Z, after this bitwise AND operation between Z and 0x3, what could be the data in Z? Either of these four. Okay, so first 6 bits will be 0 and remaining 2 bits will be either 0 0 0 1 1 0 1 1, depending on what is actual data in port 1. Okay, now we are using switch statement. Okay, so in this switch, so here in expression is Z. Okay, and this value in Z, as I told you, it ranges from it could be either 0 1 0 0 0 0 1 0 2 or 0 3 in hex. Okay, value in Z, depending on what are bits p1.0 and p1.1. Okay, all remaining 6 bits are masked. So in Z we could have either value 0 0 0 1 0 2 0 3, depending on p1.0 and p1.1 bits. Now here this value in a Z will get compared with these different cases. Okay, so first value in Z is compared with 0. Okay, if it is 0, then this part of program will be executed. If it is not 0, then it will get compared with 1. If it matches, then this part will be executed. If not, then it will compared with 2. Then this, if match found, then this part of program will be executed. If not, then it will get compared with 3, and if it matches, then this part will be executed. If there is no match, means no statements will be executed. Now suppose uh, suppose suppose p1.1 and p1.0, suppose these two bits are 0 1. Okay, then what will the value in Z? In Z there will be value 0 1h. Okay, so in a Z there will be value 0 1h. 0 1h means in decimal it is simply 1. Okay, so now value in Z will get compared with this case first 0. So there is no match, then it will go to next case. Now there is a match, 1. Value in Z matches with this case value. Okay, so then if this match found, what will happen? So these statements will be executed. So what is there? P0 is equal to, in single quote, 1. Okay, means single quote 1 means ASCII code of 1 will get sent to port 0 and break. Okay, after that there is a break statement. Due to this break, there is a break, means this switch statement will get break and program control goes down to the out of switch statement, and program execution ends here due to this last closing brace. Okay, now suppose data is 1 1. Okay, on this port 1 pins p1.0 and p1.1, data is 1 1. Due to that, what will the data in Z? So data will be 03h. 03h data will be there in Z, and it represents 3. Okay, then what will happen? Value of Z first will get compared with 0. So no match, because in Z value 3 is there. Okay, so no match, then it will go to next case, again no match, then it will go to the next case, no match, again it will go to the next case, there is a match. Okay, because 3, it matches with value in Z. So these statements will get executed. That is, port 0 will get assigned with single quote 3. In single quote 3 means ASCII code of 3 will get assigned to port 0, and here break. Due to this break, control will come out of this switch statement and program execution ends. In this way, depending on what are the position of these bits of port 1, that is port 1 bit 0 and port 1 bit 1, uh, depending on that, this program outputs ASCII code of 0 1 2 or 3 to port 0. Okay, so this is about this program, which is sending either 0 1 2 3 ASCII codes to port 0 depending on what is data in pin number 0 and 1 of port 1. I hope you have understood how to perform logical operations by using bytewise logical operations. Okay, and bitwise. More specifically, we have studied bitwise logical operators, which are majoritarily used. Okay, and uh, as per application, we can also use bytewise logical operators. Okay, so I think this much discussion is sufficient uh, for byte that is logical operators, how to use logical operators in a C48051 microcontroller. If any question, we can discuss in a live session. Okay, thank you very much.